after the last couple of lessons where we're looking at linear lines, okay, the straight lines, okay, linear functions, okay, now we're moving on to quadratic equations, okay, and quadratic equation that we're going to work with this year all look like that. ax squared plus q. Okay? Next year we're even going to add to that a little bit. They're called quadratic. Why are they called quadratic? Because there's 4 quarters. Not really. Quad means, I don't know, quad means 4, but really it's the square. Okay, so maybe that's the square. Square, 4 corners, okay? So it's related, okay? It's a square. Anything that has x squared will be quadratic. Now, what you're going to see in our exploration of all these functions that we're going to go through is that we always have to start with a mother graph. We did the same. I used that term in sine and trig, where we looked at the sine graph and then the cosine graph. And from then on, we added vertical stretch and shift and all that. So our mother graph, when it comes to quadratic function, y equal x squared. What does that look like? If I had to, because you see what we're doing here with functions, we've got a certain function, and then we try and draw a graph. And then we also do the other way around, maybe a bit later on. We'll draw a graph and need to figure out the function. Look, you want to mention? Yeah, you're right, okay? So the graph looks what we call a parabola. Let's try and draw it quickly together. When x is 0, if I substitute x equals 0, what will y be? 0. Okay, because remember, this is how we draw function. Okay, we decide on a certain values of x. Okay, maybe in the old days we just put x and y, which shows 0, 1, 2. Okay, I'll do that now, but a lot of the time we're not going to draw that anymore. We'll just do it in our head. Okay, x is 0, y is 0. X is 1, what will y be? What will y be? 1. Okay, 1 squared is still 1, so I'm going to put it here, right? 1 is there. Okay, I went up in 2s. Okay, when x is 2, what will y be? 4. Okay, 2 squared is 4, so I'm going to put a point there. You can do one more just to kind of get the feel. Okay, when x is 3, what will y be? 9. Okay, so then we can really see what's happening on this side. Now I'll just put it together. Now the thing is that Luke didn't just say like that. He said the whole thing. So we need to look what happens on the negative x's. When x is negative 1, y will be? When x is negative 1, if instead of, let's say, put minus 1, what will y be? Plus 1, still 1, right? Because minus 1 square, we square it, we're still going to get a positive 1. When x is minus 2, it will still be positive for you, right? Because minus 2 squared is 4. Okay? So it's still going to be positive. Look, you yourself mentioned it's going to be the same shape, right? And when x is minus 3, y will still be 9, isn't it? Positive 9. So we've got that little smiley face. Okay? It's not V-shaped because V-shape, we have V-shapes, you're going to learn about them if you do AP maths. Otherwise you're not going to learn about them. That's another thing. Because it's not 2 straight branches, it's a smiley face. Okay? Say again?
Like a U.
Like a U. Yeah, absolutely, like a U. Okay, alright. Yeah, that's fine. Okay, let's try and think what happens without actually substituting. If we have, instead of x squared, we have 2x squared. So now I'm playing with that a. Okay, so that was our mother graph. Now I'm multiplying, I have a equal 2. Without actually putting numbers in, what do you reckon will happen to our u? Okay, that Luke was talking about. Like this?
Yes.
Okay, let's try. Okay, right. So I'm not gonna draw the table now. Okay, so when x is 0, what will y be? 0. It's still gonna be 0. 0 squared times 2 is still 0. When x is 1, y will be 1 squared times 2? 2. Okay. Alright, do I need to draw a table? Alright, when x is equal to 0, y will will be 0. And x is 1, 1 squared. 2 times 1 squared is 2, isn't it? Okay? So when x is 1, y is going to be 2. You can see it's already above the red one. Okay? I'll draw that in green just so you can. Okay. When x is 2, 2 squared is 4. 4 times 2 is 8. So instead of 4, now it's going to be 8. Okay? I'm not going to draw it. I'm not going to have enough space. But when x is 3, y will be 9 times 2 is 18. I don't need it somewhere there. So you can really see that actually the smile, now we'll call it a smile now, we'll see why in a second, is actually skinnier. On the other side, okay, will there be any change or is it going to be the same values? It's going to be the same value. You can see it's always going to be the same values because it doesn't matter if x is positive or negative, that square will turn it to positive. So when it was minus 1, okay, it's still going to be 2. Minus 1 squared is 1 times 2 is 2. Minus 2 squared is 4. Positive 4 times 2 is still going to be 8. So we're going to have this skinnier smile. Sharper U. That's quite bad the way I drew it here, but you get the picture, okay? Alright? So it's not going to pull it like that. On the opposite, it will make it skinnier smile. More like, can't do that, okay? But Luke did say, maybe like that. So can we think about how we can make up, this is by the way called the parabola. I don't think I mentioned that word. All these shapes are called parabolas. All these graphs, these quadratic graphs are called parabolas. So how can we make them stretchier? Use what? What kind of A? This is the only kind of thing we have now, A. So we saw that if we go from 1, because here we can say, all right, there's 1 times x squared. To move to 2, well, let me ask you another question first. What about y equals 3x squared? If I had to draw y equals 3x squared, what do you reckon will happen then? Even skinnier, okay? I'm not going to draw it accurately.
Negative 1.
Okay, so I'm going to ask the question first, Ollie. Okay, I'm going to ask the question again. How can we make something that will be stretchier than the red one? Ollie mentioned negative 8.
Or half x.
So which one?
So what? Negative 5x.
Okay. So Luke, let's just go with Luke and what Ollie suggested. So let's have a look at half. So I'll use the black pen maybe. Okay. Y equal half x squared. Or we can write it as y equal x squared over 2. It's the same thing. Okay? So, again, let's have a go at it. Okay? A few points. When x is 0, it's still going to be 0. Okay? Put 0 here, it's still going to get 0. If I put 1, what will be the y value? Half. Half is going to be somewhere there. The same thing, by the way, if I put x equal minus 1. There is a symmetry. This is an important point. There's symmetry along the y-axis. So it doesn't matter if x is 1 or minus 1, I'm going to get the same y. Why? Because of that square. It turns the negative and positive into positive. Right, let's move on to 2. 2 squared times half is 2. Okay, 2 squared is 4 times half is 2. So when x is 2, y is also 2. You can already see that it's becoming stretchier. You put 3 squared is 9, divided by 2 is 4,5. So it's somewhere around there. Okay, obviously the same thing if I draw here. Okay, somewhere like this. So we definitely have a stretch here. So x is equal to half. Okay? What our conclusion? Okay? If let me write it here and I'll pause it after this. So if A is larger than 1, it becomes skinny smile. Skinny smile, how would you call it? Narrow smile. Okay? If A is smaller than 1, and I will still say larger than 0, we haven't looked at negative 1, then it's going to be a wide smile. Does that make sense? Let's just pause here for a second and breathe. Okay. Right. So we looked at what possibilities we have for A when it's larger than 1, narrow smile, and between 0 and 1 more wide smile. But Ollie mentioned, what about negative? So let's have a look with I'll draw. We start with green. No, we start with red. So I'll do with red. Okay. What if I have? I'll write down here y equal minus x squared. What is that going to look like? Yes. Yeah. Here we go. So I get indication here from Ollie and Luke. So what we'll have is not a smiley face. We will have a sad face. Okay. Let's just look through a few points. When x equals 0, it's still going to be 0. Okay. All our parabolas at this point go through the origin. When x equals 1, what will y be? Okay, this is maybe I'll write it. Okay, x, y. When x is 0, this is y 0. X is 1. 1 square. What will be the answer when x is 1? It is going to be minus 1. Why? Because y equals minus 1 squared. Now, why isn't minus 1 squared equal 1? Some people will say, hang on, he's squaring minus 1, so it should be 1. What do we do first? Are we squaring and then times it by minus 1? Or first of all times by minus 1, then squaring? Squaring first. Do you see the subtlety here? Okay? Here I'm squaring the 1, so that's just 1, and then I'm just end up with minus 1. Okay? When I had it here, if I put minus 1, y equal minus 1 squared, that is going to be positive 1. Do you see the difference between that and that? If I have these brackets, here I've got this brackets, right? I have to put minus 1 instead of x, and I'm squaring it. Squaring the whole minus 1, so I'm getting plus 1. Here, first of all, I'm squaring the 1, and then putting the minus next to it. It's a very important point, and I'm sure in grade 10 some of you still get it wrong. Okay? So the answer here is going to be minus 1. When x is 1, y equal minus 1. By the way, what happens if x is minus 1? Okay? If I put x equal minus 1. Okay? Let's have a look. Y equal, I'm going to put minus, I'm going to get rid of these guys. Minus 1 squared. Right? I have to put that minus, because that's in my function. And then instead of x, I write minus 1. What will be the answer for that one?
Minus 1.
Will be minus 1, right? Because minus 1 is square is 1. So it's going to be minus 1. So the answer is still minus 1. It's not positive 1. So we still have a symmetry along the y-axis. Okay? When x is 1, okay, the answer is going to be y is minus 1. When x is minus 1, y is also minus 1. Okay? Which is like what you guys said, it's becoming sad face. When x is 2, y will be negative 4. Y equal minus 2 squared minus 4. So x2 is minus 4. X equal minus 2 is also going to be minus 4, just the same way. Okay? If I write minus 2 squared, still going to be minus 4. So we have a sad face, right?
And the plus in the wrong place.
Living here, isn't it? And I'll carry on like this. Okay? Alright, so it's a sad face. Okay, no, I'll get that in a minute. This is getting a bit long. Okay? Without calculating, can we figure out what will y? This was y equal x squared. Then we had y equal 2x squared, which was narrow face. What will be y equal minus 2x squared? What do you reckon will that be? What do I need to do to this red to have minus 2x squared? It's going to be a skinnier, sad face, right? So again, I'm not drawing it very carefully here, but it's still going to be sad face, but skinnier sad face. Okay? So I'm going to add two things for this. If a is smaller than 0, then we just have a sad face. Okay? If a is smaller than minus 1, it's going to be a skinny sad face. Okay? And I'm learning something new here, which we touched on it last time with linear. I didn't really I didn't really, I thought about it, but I didn't say it. Okay, when we add a minus here, we take a function and we add a minus. What are we actually doing? We are flipping around which axis? The y.
X-axis.
Exactly. Look at this. This was y equal x squared. This one is y equal x squared. This is y equal minus x squared. Yeah? This is y equal 2x squared. This is y equal minus 2x squared. If you add a negative, and this is true for all functions, not just for parabolas, it's also true for linear graphs. If you add a minus in front of the fraction, what you're doing, you're flipping it. Or the more mathematical word is reflecting it. You're reflecting it along the x-axis. Now look at that red graph. You're just folding it, and you get this graph. How do you do it? By just simply putting a minus. The same thing with the green, and the same thing will be with the blue, isn't it? Okay? If this is 3x squared, this will be minus 3x squared. Does that make sense? It's the same thing with the, I'll just finish up here, okay? If I have, I'll draw it here. If I have y equal 2x plus 1. Okay? If I put a line or minus in front of the whole thing, okay? So y equal minus 2x plus 1. And then I have to put brackets. I put a minus in front of the whole thing. In other words, y equal minus 2x minus 1. What I will get is a line which is flipped over, reflected over the x-axis. Very, very important point, guys. Okay? Putting a minus in front of the function, you're reflecting it over the x-axis. Right, I'll stop now. Okay? And what I'd like you to do is page, where are we? Yep, now we'll pass that point. So, page 116, exercise 2, and I'd like you to do parts A, B, and C. A, B, and C. I'll write it down for you guys in one moment. Okay, we'll carry on from there.